So I am Shivani Joshi, your webinar host for today. I would like to welcome you for the session on API design best practices, where API design is broken down to its fundamental design blocks and best practices at each level will be discussed. Before we begin, I would like to update that all the questions will be addressed at the end of the session. Not to delay much, let's welcome our speaker and subject matter expert, Pradeep Tallogu, Enterprise Architect and Head of Integration COE at Prowess Software Services, to lead the session. Over to you, Pradeep.
Thank you, Shivani. Hello, guys. I'm really glad that you are here. Just a brief introduction about myself. I'm Pradeep Tallogu. I am a Center of Excellence head here at Prowess Software, and I work with various groups, delivery groups in our core area of enterprise integration. API management happens to be one of our core offerings because naturally we are into enterprise integration, and API is the go-to standard for any company or any enterprise that wants to digitize. So without much further delay, let's get started. Shivani, would you please give me the access to share my presentation?
I've shared. Can you please check now?
All right, thank you. I hope you're all able to hear me. So without much delay, let's get started, guys. So one of the basic things that you would see with any digitization process is API management, and that is the reason we have taken up this really fundamental design practice of how you would build APIs for integration. Here is a brief agenda of what we are going to cover over the next 1 hour. We're going to see first the big picture of what API management is involved of. We'll take a look at a high-level bird's eye view. We'll introduce a few components in there, and then we'll narrow down our scope to exactly what we are talking about today. We'll also start off with the APIs, what they are and how they're done. Web APIs especially, the reason I say web APIs is because APIs can be within the same machine. You could still use APIs, but we're talking about APIs that span across the network. We'll break it down. We'll break the API down into its design elements. We'll take a look at what the designing URLs are. What are the considerations in designing URLs? We'll also take a look at how we would design the representations of entities that are part of our resources, rather, that are part of this API design. We'll also take a look at how collections are represented. We'll talk a little bit about various HTTP operations, and especially a note about HTTP patch, why you should consider that and how it helps by actually having a separate operation just for patch. And then we'll take a look at some considerations for what kind of response codes you would use, what would be the headers that you would consider, and how would you use that, and basic considerations for authentication. After that, we'll get into a little bit of discussion on how and why you would consider complementing your API design with an SDK. And then we'll stop it. We'll close it with closing remarks, and then open it up for Q&A. So as you can see on my screen now, is the various components that are involved within API management. As you can see, the central components in this are the API management, gateway. There is a developer portal. There is also some management, utilities that you could use as part of your API management offerings. You will see that the API management is interacting with backend APIs. It could be, these backend APIs could be in the form of regular, web APIs that we talked about, or it could be, various other offerings. If you would go with Azure, for example, apart from using a backend API for your interaction, it will also allow you to use the Azure deployed functions that you could actually use as a backend API. So uh, in general, the generic ones are the backend APIs that API management would interact for you, and then expose them over the gateway onto the developer community or for your applications. Another part of API management is the developer portal. One of the most useful things for your developer community onboarding. Developers who actually build your applications, one of the things that we need to stress while designing is to ensure that there is a clean onboarding process for developer community. That is one of the primary reasons why you would really focus so much on API design, because there's with so many options out there for developers who are building apps, it's easy for them to just pick and choose the best implemented one. And if yours is not fitting into what they're looking for, or it is taking too much of a learning curve for them to get used to your APIs, then it's easy to just pick another. If you actually observed any company that is providing its products or services, they would have a API strategy. How someone would, whether it is B2B, business to business, or B2C, right, business to consumer, either way, customer, either way, if they do not have an API strategy, it's probably not in the right direction now, because everything has gone mobile, everything has gone on the internet. And if you want people to really use your services, you better have an API exposed for consuming your services. That's what you would see. The other box that is here is for developer community, and they develop these apps, multiple different apps, of which these apps may not be only communicating with your APIs, right? It could be a combination of a lot of other services that it is consuming, and yours is one part of it. And then these APIs are used directly by the user community. And with that as the full landscape of where API management stands, our focus for today is to actually ensure that the APIs that we design are easy for developers to actually invoke and use. The easier they are, the more familiar they get with the APIs. It's important to understand that the developers will use it more. So basically, you're trying to fit everything into certain standards so that it is really easy for whoever is the consumer to pick it up and take it off from there. All right. So with that in mind, let's get on to the next one. A brief introduction about APIs, HTTP, REST. I will not read out this slide, but I will just say that APIs in theory, they need not use HTTP, but really they don't have any other choice. If you look at how HTTP has hardened over time, decades of usage, and really it has become such a mature protocol for all the data transfer across the World Wide Web. It's really the only choice one could think of for implementing your RESTful APIs. Another reason again is HTTP is actually an implementation of the REST protocols. So REST is again it stands for representational state transfer, and basically REST is an architectural style of programming. And then HTTP is based out of all the theory that is in REST, or all the specifications that REST comes with. Those are implemented in HTTP. So really, it's a natural choice if you want to go with building your APIs. And I really don't see, and no one really sees, any other protocol that can be implemented in such to build these RESTful APIs. All right, so with that, let's get on to the API design elements. As you can see on the right side, you would see how URL is invoked, and then there is a request URL, you see a response, and along with the response, you also have these headers. And within the request as well, you see that -h, which is actually a header, right? So there are various elements, if you look at it, that you could actually look at for designing, consider for designing. So the first thing out there is representation of resources. Basically, the response body here is a representation of a resource. I've taken the screenshot of one of the most popular, sample object that is provided as part of your pet store provided by Swagger Hub, really. And the response body you see there is the resource object representation of inventory. As you can see in the request URL, I'm actually invoking inventory. So that representation can be optimized. You could have a few considerations that we'll talk about later in this presentation about what are the considerations when you are building that object representation. You also have standard HTTP headers, and highly recommend you to use the existing headers so that your the developers who are using it are already familiar with all these HTTP headers. Because of this being widely used as a protocol, it's better to use what is already there. And then there are a few things that you need to consider that we'll talk about later in the presentation when you are designing your the response of your operation. We'll also talk about URLs and URI templates. When you are considering creating a URI for a given resource, there are certain considerations, like it is similar to how you would do a database modeling, right? You will have a list of resources and you'll have some relationships, and end of the day you want to ensure that these resources are tied up with the relationships in an optimized way. Similarly, we'll talk about how URLs and URI templates can be used so that you can optimally design your API model. There are a few other things, required behavior by clients, which is actually something that you can set and that needs to be used by the clients. We'll not talk a lot about this. We'll talk about what is in our control from the server side here. So let's get into the meat of it now. The very first thing that you should consider, obviously, is the URL, how you are building your URL. That is your I'm talking about the base URL. So as you can see here in the example that I've shown here, the base URL is the HTTPS ://www apiuniversity.com. That is your base URL, and students is your URI, /students is your URI. So one of the things that you really want to ensure is that the base URL is really well known. Someone should not really open certain they shouldn't go into a vault and get the base URL. It should be really easy to remember for developers, and it should be easy to understand and also contextual based. Okay. We'll talk about nouns over verbs in the next slide, where I've elaborated a little bit. Basically, when I say you have to ensure that your resources should be noun based rather than verb based. As you can see in the second bullet point here, there is a URI that says get all students, right, or create student. You also have /update student with an ID. So you need to understand that as part of your API URL, you have two components at a very high level. One is the URL itself. The second is the HTTP operation. So there is a combination for any operation for you to perform. You have a combination of the URL. Along with it, you have an operation that you are going to use it for. Now, you already have operations for your CRUD, operations, CRUD services. I meant when I say CRUD, I mean, create, delete. There are four, operations. Basically, in HTTP terms, they are, HTTP post, HTTP put, and you have a delete, and you also have a get, right, to retrieve your data. So these are equivalent to the CRUD operations, four operations. So when you already have a HTTP operation and you have a URL, you don't really need this verb here that says get all, because if you are going to use this URI with the HTTP operation of get, then it is just basically redundant. The other thing about this is it will also keep the developer guessing about what your URI could be. Some might call it get all students. The other system might say retrieve all students, right, which basically means the same, but still the developer on the other side is trying to get familiar with the various operations you are putting in there, with various URIs you are putting in there. So it is always recommended that you go with this data oriented approach rather than function oriented approach. Basically, get all students is a kind of function oriented name. So there is a small comparison table that I put in here that basically illustrates the point I'm making. So you could either say students, which is self-explanatory if you use with a get operation, or you could say get all students. The recommended approach is using the data-oriented approach. And similarly, you will also have, you could use the query parameter with ID equals to, or you could also use a path parameter when you know that that is the primary key by which you are going to get retrieve students, right? Some more examples down in the table that will showcase the various ways in which you can represent the same thing. Moving forward, let's talk a little bit about representations. So just to give you what I'm talking about here is, it is the object that is retrieved when you invoke a get operation. That is the resources object representation. Usually that object is your JSON object, or that could be your it could be any object. It does not necessarily have to be a JSON object. So why is JSON used? Basically because it is really easy to understand. Why is it used more than XML? Maybe because in fact it is because it is lightweight and more self-explanatory. It doesn't carry a lot of tags with it. It is just as much needed info you have in there. That's one thing, and it will keep things simple. And since it is the dominant media type, simple to understand, another reason why you would use JSON is there is that format is really well understood. It is used it is basically ubiquitous. It's all over the place, and there are well understood parsers, and really lightweight as well. So that's one of the reasons you would go with JSON. Recommended approach is JSON. And you need to if you observe into this object representation that I put in here, you will see that there are certain types of properties in there. The first you would see is the self property, and then you will also see that there are two more links here. One is students and one is staff. So understand that this is actually object for the resource department. So when we are invoking get operation, on a certain department, you're getting this back on this department ID of D789 in this case. So when you get this, it's not really necessary on the face of it. You will feel like, why would I even need the self link, right? We'll get to that in a little bit. There is a a deck, there is a slide especially talking about that and the kind. We'll get to that. But links is something that will basically help you in general. It will help you uh, reduce the amount of payload you are actually carrying from one place to other place. Now imagine if I was to load all of this payload with the information of all the students and staff. That would be a really huge payload, right? And you really don't know if that is used or not. But with this, if I had given just this link here, then the client has an option of actually using that link and then getting to the student that he wants to, or even if he needs all the students' info, he can still get that. So that's one of the reasons you would include links, and that's a best practice, because you would have the info of how to get there, and you're not even overloading your object representation, right? Now, there is a debate about, whether the link has to be an absolute URL or a relative URL. There are pros and cons on both sides. It's basically on the context and how your audience are. If your client is able to, get the absolute URL or the base URL rather, and then append your relative URL all the time, then that's nothing like it, right? It's great. If your client or if your users or the consumers are not ready to do that, they actually want the absolute URL, then you could have kind of a layer before you actually send it back to your client, wherein you append the needed information. Absolute, you can make it an absolute URL and send it back. But there is always, if you are going to use absolute URL as part of your storage itself, as part of your object representation, then there is definitely a need, need for extra processing when you're actually moving from one environment to other environment, and there could be some conflicts that you will have to resolve. But again, this is a decision that you can make based on what has already been there in your company, in your enterprise, and then based on the maturity level of the API culture across your enterprise. So in some enterprises, they really grasp it quickly and they do the transition quickly. In some enterprises, it might take a time. In fact, within the same enterprise, some teams can do it faster, while some may take a little more time to understand. So it's really up to you to decide which one is the best for you, and then take it forward with that decision. I think in this, that is what I wanted to explain. We'll go on to the next one. Yeah, so this is the one that I was talking about, where we'll elaborate a little bit on these two properties that we had as part of object representation. One is the self link, right? One of the reasons you would need, or you would find a need for self property, is basically when you have a client that is invoking a certain request and then getting the response back. It is possible sometimes that there are different implementation units, one that is actually sending the request and the other that is actually receiving the request. So it is always good to have that context in there in your response, so that the response processor or the implementation unit that is actually processing your response can understand the context of where this response is coming from, or why this response has come, and what was the resource and what was the operation that is invoked due to which this response is here. And based on that, if these implementation units on the client side are different, then the response processor will know the context. Another property here is the kind property. Kind basically is similar to what you would call data type in the data world, right? So you could have different types of uh, object representations, different objects, in fact, and it is possible that in intuitively you might not think that it is for a given request you will always get a similar response back with a similar kind, but sometimes it is possible. If you will go through a use case later in this presentation where it's possible that you actually send out a request for something, and you might not always get the same object type back. Depending on the context, you might get a different one. For example, let's go through this example wherein you have a university and you have a object called student. Now the student has a certain set of properties. Due to an exchange program, let's say there is another student who comes in, there are a set of other students that come into a different university, your university system, and that university, that students properties maybe are different. Maybe there are few extra properties, right? Or there are some properties that are not available in the student system that you already have, or the university system that you already have. Now if I send that object as is, then it is possible that the response on the client side, the response takes a look at this kind and says, I mean, if there is no kind property, then it expects the same response back in the same format, and it might actually run into a parsing issue. But if you had a different kind, let's say exchange student is the kind for object that is coming from an exchange student, then the processor on the client side would actually understand that this is a kind that I can ignore or I have to process differently. So that is where using kind as a property helps. Okay. So moving forward, a few items here. One of the things I just wanted to stress here is that your entity URLs or the resource URLs should be really intuitive. If you look at the example on the top here, you can compare both. One is the top one shows you a URL wherein you can intuitively make out that AC123 is probably the student ID or the primary key of a student, and that is why you are going to, and that is how you form your URL basically. But in the second case, you would spend a lot of time and energy in trying to parse it, and it might not even result in the right resource all the time. So instead of using session IDs or UUIDs, you could actually use something more intuitive and something that you can easily make out or recreate, even if it was for a different resource ID, right? The next is permalinks. Permalinks are basically, it can be bookmarked by the client, and you basically have to ensure that these links, when these are invoked, it should not say that this kind of URL does not, exist anymore. Maybe someone has bookmarked a certain link, and a week later they come back and use the same bookmark. It shouldn't say it doesn't exist anymore, because you may expire it after a little while and you can say that this is not available anymore, but you just cannot say that it is not a valid URL or something on those lines. You cannot, if you want to give developer a good experience. So one recommendation is, you can use a type as one of the URI component, and then you can use the UUID, and then you can set an expiry date on onto the time that you want to put there, save it for retrieval later on. Moving forward, this is one of the blind spots, you could say, that you should be careful about. This is about designing entity URLs, and it is natural for us, especially after so much of programming that we have done, to think of entities in a hierarchical way. Now, if I would try to put student in a certain data structure, I always think about, the student is contained inside a department, and a department is contained inside a university, right? And naturally, we go into this designing the URLs in such a way that you have this base URL followed by your, the higher element in the hierarchy, and then the lower one. But if you actually think about it, if you wanted to retrieve the information of a certain student, for example, and you have this hierarchical URL wherein you have a university, and then you have a department, and then you have a certain department to go to, and then you have your set of students, and from that you are going to pick one student based on his ID. Now that is to pick a student, to retrieve the information of a student given a student ID. It is not enough for you if you just do that, right? You will have to go in and get the department ID to which he belongs, and then you would go in and create the URL to retrieve student. If you looked at the one on the right, the university 2, with student 6 as part of that university, if you design this well, it's actually the other way. You, with the student ID, you can get the department as well, because all you need here is the student ID. You could say this is my base URL / students / your student ID, and with that you can get back, as part of your students object representation, you can get back all the various properties of student, and then as one of those properties is also the department to which he belongs. So just be careful of these blind spots where you try to design a lot of hierarchies and then you fall into that trap. So this is about, the next one is about query URLs. People who have worked a lot on RPCs, a lot on databases, it's very natural to actually put all the filter criteria into a query parameter, right? Because you're just going in there, putting in query parameters, and it occurs naturally to you when you're designing. But just make sure, like it was discussed earlier, that if it is a primary key of that object, then let it be on the path and be a path variable or path parameter. And if you want to filter it down further, let's say you want to filter down, beyond all the students who have joined in the year 2002 or 2012 or 2022, right? So you could basically, for the second criteria that you have, you could use a query parameter and use these query parameters with care, because it is very easy for developers to actually, if there are a set of 10 properties and you start creating filters based on certain properties, then it is easy for the devs to assume that there are filters for other properties as well. So it should be documented well on your developer portal, so that the devs actually understand which ones is the one on the path parameter and which ones you can filter it out further on. Okay. Another reason you would use this kind of path parameters is you would be able to do graph traversal. Now, when I say graph traversal, this is a little bit of what do you call, uh, kind of traversing through the object representations at each level. Now let's look at the bottom of the screen and see, investigate that URL. You have a base URL, and followed by that base URL, you have students as a URI. And as part of the students, you are filtering it out based on the student ID, which is 123 in this case. Now, if you stopped at 123, you would get an object representation of a student. But that object representation of the student has what you have, it has a property called department, which gives me the department ID to which the student belongs, right? And that department information. Now, if I get that department info, I can actually go into that object from there, and then get a list of all the professors that are working for this department, right? And now that I have this professors, which is actually a collection of different, multiple professor objects. From there, I am filtering further on a certain ID. So what I'm really trying to say here is, if you used a query parameter for everything and you don't have a path parameter on a certain ID, then this kind of graph traversal is not possible. You cannot actually implement something wherein you move from one object representation type to another one. All right. So moving on, I really don't want to spend a lot of time here, but basically I have generalized what I have out there in the previous slide, so that the relationship name here, in our case it was students, right? And when you stop there, you get a collection of students, and then you can go further and say student ID, which means you get a specific students object. And similarly, you can keep going for your graph traversal. And then there is another blind spot that we were talking about in terms of hierarchies. So I put in another one here, which says the relationships can actually be expressed symmetrically. So looking at this, the second bullet here, you could see that in the first case, I am getting students. From those students collection, I am going to a specific student, and then I'm going to get all the courses that this student has enrolled for. Now, if you look at the second URL, I'm actually going to the courses that are offered in the university, going to a specific course again, and from that specific course, I'm going to actually traverse and get all the students that have enrolled in this course. So it is a many-to-many relationship, right? Students can have multiple courses that they are enrolled into, and each course can actually have multiple students that they are enrolled into. So these are relationships are symmetrical, so don't jump into the conclusion that they can be hierarchically placed. All right. So the third bullet you see is about filtering collections. Basically, it's the same thing. You could go to a certain object representation and filter further through a certain query parameter. All right. So that was all about persistent resources. Whatever we talked so far was about resources that are actually persistent, stored somewhere in the system. Their state is maintained. Now, you can also have some use cases where you would not really invoke a URL to get the state of a certain resource. You probably want to translate something, language translation. You could be trying to calculate something, or you're converting something, which is actually a function that your system is offering. It's offering you a function. It is not offering you a service to get the system state or the resources state here. So in this case, it may be tempting for you to actually say, uh, translate to a certain, certain language, translate to English, for example, or translate to French. So that will make it a verb form of URL again. So the examples below here just show that even for cases where you're dealing with non-persistent resources, you can still use the noun forms. For example, you can, in terms of our regular use case that we use, which is a university-based services, if you are trying to get the tuition for a certain department in a certain semester, then you could use it through the query parameters as shown up there, or as the path parameters as shown here. One note to understand here is, it's not always possible. Let's say you're calculating the income tax, right? It's not always possible for you to put all the various possible variations, various parameters into your URL. So it is absolutely fine that you actually consider using a body for that, for that request. And if you're going to consider a body, then you would use probably a post function, right? uh, there is a bit of a conflict in the semantics when you use a post and you're actually getting something back, but you're not using HTTP GET. But as long as you know what you're doing, and as long as you understand this is an exception to the rule, that is still fine, right? Because you obviously cannot put all the various properties that will determine a huge calculation that you have to get back on. So sometimes it's possible that you go beyond just the regular semantics of HTTP, but yeah, you still have to get the work done through in the most optimal way. So in some cases, you would use HTTP post with a body. Going forward, this is just a description of, just a quick overview that even if you're using collections, which is actually, an array of objects, for example, in our case, students, right? So it's basically you treat this as its own, as an object representation by itself. You need not actually return an array. You can have array as part of contents property that you have here, and in that case you will also be able to place certain links. For example, in this case, certain properties like self and kind that you put at the collection level. So instead of just sending back an array, you use the collection. You use a outer structure for collection, and then you can store the properties related to that collection at that level. Going forward, a quick word on HTTP patch. I won't spend too much time, but just I want to tell you that there is a certain, consideration about HTTP patch. If you think that HTTP put can do everything that patch can do, you're right, but there is a catch there. When you do HTTP put, the expectation or the semantics is that it is going to replace the object that you have it currently. So the onus is on the client to ensure that he only updates the properties that he wants to, and retains the previous values for all the other properties. But in case of patch, if you implement this right, then you can only update the ones that you want to. All right. So that's why, just for completeness, make sure you use HTTP patch, and expect your clients also to use patch wherever required, instead of using put and overlaying the object altogether. A few recommendations. There are a lot. If you go out there and take a look, there are a lot of ways to implement parameters for your pagination. Just put some high level recommendations here, where you could, at the end of the day, all you need is two parameters. You want to know the offset from where you want to get your results from, and you want to know the limit of how many you want to. So you could, the example here is descriptive enough, where I would say, followed by URI, you put in a limit and offset as the two parameters that you would use, and implement it on the other side so that you only get those that response. Another method of reducing the bandwidth or the payload size is through getting partial response. One of the ways of doing that is actually implementing a way wherein they only pick the fields that they want as part of the response. This actually helps in a lot of ways, not just in reducing the bandwidth. Tomorrow, if your object representation gets updated with multiple other properties, you will still only get the properties that you requested for, and thereby you're not actually changing on the client side the existing code, right? So it will help you in that way as well. A note on headers and status codes. There is a lot written in here, but I will tell you very simply. The rule of thumb is to ensure that your HTTP codes, HTTP as a protocol, is a very mature protocol. It has a set of response codes. I mean, you will not find anyone using internet who does not know what is 404, right? The code 404. I think everyone would have used it somewhere and encountered it somewhere. So basically, the goal is to use the codes that are already that everyone is already familiar with. Don't recreate new codes. Use the ones that HTTP provides as part of its protocol. And there are a few other things as well, right? As part of the headers, ensure that when you use a code, for example, there is an error code 405, which is basically sent out when you invoke an unsupported method. Let's say on students, there is no method called patch. You invoke the HTTP patch on a student resource. Then it gives you a 405 indicating it is an unsupported method. But ensure when you do or when you encounter such a thing, right, on your server side, you also, populate the header called allow, which gives you a set of all the methods that it actually supports. So this helps in developers using this efficiently, using your code efficiently. All right. Authentication, there is no better way than using OAuth 2.0. You have every control that you need in terms of, when you want to disable someone's, authorization, or when you want to give, it's all remote control. So better, that's the best recommendation we could say, is go ahead and use OAuth 2. All right. So coming to the last closing thoughts, I want to just say that there is sometimes there is a need for an SDK by developers. It is usually, developers usually think that there is SDK is doing something different than actually invoking the API, but under the scenes, SDK is still a wrapper over your API. So as long as you have a well-designed API that caters to all the design best practices that we discussed about, then you basically have that granularity of being able to update or create or delete the specific resource that you are going to work on. So your SDK will just be a wrapper on top of it. One note is to know your audience, see what your audience are using, which language they're using, and you get those ready to go SDKs for that programming language of their choice. Also, keep a list of samples that you can use for various operations on your APIs in various languages, in various programming languages, or the popular programming languages. All right. So with that, I will just conclude. There is a lot happening in the digital world. It's not something that we need to elaborate more on, but just know that in conclusion, just make sure that one of the primary things to do is to ensure that you leverage the familiarity and the knowledge that the users already have. All right. And then once you are able to leverage that familiarity through the various practices that we just discussed, then it is easier for developers to onboard and actually start using your APIs. They get a head start as soon as they understand what the entities we are working with. All right, so I will stop here. Shivani, I think we are good with what we wanted to cover. If there are any questions that you have, and if you want to, bring up anything from the audience, this is the time. Thank you.
Thank you, Pradeep. It was a really exciting session. So I request all the participants, if you have any question, you can drop in there or you can raise hands. I'll just transfer this to Pradeep. Okay, we have a question from Rocky Gupta. Okay, just give me a moment. You want to ask? Yes, Rocky, you can ask your question. Can you please unmute and ask, or you can drop in your question in the chat box, or maybe.
Yeah, is I am audible?
Yes.
Hello.
Yes.
Yeah, hi Shivani, hi Pradeep. Honestly, before I joining this session, I checked with this API in Google. So what I seen like is some abstractions, and it's related to computer programs and computer. In between, yeah, we are coding. By interacting with you, I just get to know like HTTPs and REST and all these are related. So as I am like it was my first session. Can I have this presentation? So
Oh, okay. Yes, Rocky. So we are actually, if you are enrolled, we'll actually send out a detailed white paper on the items that we discussed. So if you are on it, you'll actually get a detailed set of white paper that we wanted to send out. So all this and more than this will be covered as part of that.
Yeah, exactly what I need. Just because our organization don't have it is restricted to share the presentation. So I asked you, I haven't taken a screenshot of it, right? So I'm just asking if is it possible? I just need this. So I will go and explore what this
Sounds good.
anyway, I have noted the headings, topics, all
We will
topics.
be sharing the detailed paper, Rocky, so you can go through that, and maybe if you have any question, you can drop in your queries at the end. We have mentioned our email ID also, so you can take up your questions and post it on our email.
Yeah, Shivani,
Yeah.
sure.
Okay.
Thanks for
Pradeep,
supporting.
Pradeep, we have another question from Naveen. How to manage different versions of API?
Yes, sure. I'll take that. So versions is kind of a tricky subject, especially with APIs, because just rewind about half an hour. What we were talking about, the property kind, right? We had a property that said, if you are getting, we went through a use case where we said, whether it is a student object that we are getting back or an exchange student object that we were getting back, right? So version is tricky because in this case, in our use case, we really didn't do any changes to the version number that we have as part of, most URLs have as part of the URL, there is a version number as well. But here, without really having anything to do with the version number on the URL, we actually managed the compatibility, right? There was a change to the system. There was an additional object that was added, but still we did not need to do anything on the client side to update it. Not even, the client is not even saying that I want the latest version. They're getting what they wanted. So, but this is a debatable, topic, because sometimes some enterprises are very strict on actually having version as part of it. So usually in most applications and most API implementations, you start with v1 as part of your version, and then if it is really well designed, you don't need a v2, because uh, most of the properties will take care of how the implementation unit on the client side is actually going to process it. It is possible, actually it's happened many times that they come up with the next version as well, but only if there is a sea change, if there is a lot of change and you want your clients to make big changes on their end as well, then you would do v2 while you are still supporting v1. All right, I hope I answered your question.
Naveen, is there anything else okay? We have another question. Is there any recommendation we can go for camel case URI or lowercase with hyphen for word separate? Which one is better?
Oh, okay, I see that question. Basically, there is really no recommendation that I would say. The only recommendation I would actually profess is to ensure that you are in line with the various systems that are already in place at your enterprise. If you are building from scratch, it's a personal preference. Again, I wouldn't, if I'm talking about an entity, right? If I'm talking about building a URI for an entity, for a resource, I will only use lowercase. I will not even use dashes unless it is really needed, right? So it's a personal preference, but the only recommendation I would make is make sure that you are actually using the same same standard across all of your implementations. Okay, any more questions?
Yes, we have another question. How can we handle CORS at generic level? Because sometimes even with setting allow access origin in header, still the API may throw an access origin error.
How can we handle CORS at generic level? Because sometimes even with setting allow access origin header, still the API may okay, so this is this is actually something related with the platform that you are using, I guess. And this is really about how you are how you are configuring the tool that you are using, basically, right? Rather than the design part itself. It's kind of, I would say, each tool uses its own way of handling this cross origin kind of how you handle your cross origin requests, right? So yeah, I don't have a specific answer for your question. Basically, you are trying to it's about how you debug in your own platform of how to handle that. Some could be using WSO2, some could be using MuleSoft, some could be using a TIBCO TCI implementation, Apache. There are a lot of different platforms, and how it's actually happening through the flow with your specific platform. It depends on how you want to do that, but definitely not part of the basic fundamental design considerations that we are talking about today. All right. Any other questions?
Somebody has raised hands. Let me just see.
Okay, I think we are right on time then. Shivani, over to you.
Yes. Okay. So I believe there are no more questions. Okay, Pradeep, I guess there are two people. Let's just allow them. I guess if there's any question,
Sure.
shall we take this? Yeah.
Sure.
Okay. We have a question. I've allowed you to unmute. Can you please?
This is just
As of now, we are good, fine.
yeah. This is simply thanks, very thanks to Pradeep. It was really very nice explanation for everything, and
Sure,
really great knowledge.
Thank you for being on. Thanks.
Thanks, everyone.
Yeah. Thank you so much, Pradeep, for your time. Thank you to all the attendees, participants, for your time for this webinar. And I hope that we were able to answer your queries that you have. And thank you so much.
Thank you all. Bye now. Have a nice one.